for our Sandbox project, we isolated the tumors in various DICOM images, and we made our code work with various images at once, also known as batch processing. So for our second line, we did clear all and CLC, which clears the workspace and the command window. Then we used the dir function to find the file information for each DICOM file, and we named this as names. Then we found the size of our structure, and we were in the core, and the number of columns or rows should correspond to the number of images we have. Then for our structure, we extract the names, and using that, we use DICOM read to extract the data for each image into a cell array called CT image. Now for line 14, we have another for loop where it goes from 1 to the number of rows, and we make a figure for each image. And using our previous cell array that has all the data for each image and indexing that, we binarize each image into a new cell array called binary image. And then we display each image in its corresponding figure, while also using color map gray to make sure to make it grayscale. And we use the title of binarized plus the number of the figure. Now for line 22, we have another for loop, which goes from 1 to the number of rows, which corresponds to the number of images. And here we use region props to get the information out of each binary image. And here, most important, also we take the size of each of our cell array of region props for each image into a cell array named W. And then for line 28, we do another for loop, and we have an outer for loop with the value k, and that goes from 1 to the number of images. Then using our previous cell array that contains the size for each image, we make a temporary value called size w. Now for our inner for loop, we take that value, or we make a value from I equals 1 to the size of that, or the size of that corresponding image. And then going back to stats, we now extract the area, and we make a new matrix simply called area, where each column in that matrix corresponds to the number of, or each column in that matrix corresponds to an image. We also extract from our stats structure, which is once again from using the function region props. We extract the bounding box of each image, and we make a new matrix called bounding, and each column in that matrix corresponds to a different image. At line 37, what we do is we have a for loop nested with another for loop nested with an if statement. And here what we do is we check the value in each column of area or our previously made matrix area, and we check if it's either greater than 25 and less than 800, which we, after trial and error, we decided is the best values for isolating the tumor. And we have a counter that counts how many tumors are found, and then we index the value of our area and make that index value and make it into a newly made cell matrix called index. And then that index has a lot of blanks or blank values. So we use in line 46, we use the function self_fun and is empty to remove those empty values. So now for line 48, we have a for loop, an outer for loop with an inner for loop with a nested if statement. And here what we do, while we're trying to remove the blanks values in our previous index array, we merge everything into a single column, but we don't want that. We want to separate the values into their corresponding column, since each column should represent a image. So what we do is the second value of each index matrix, we see if what image it corresponds to, and then put that into the corresponding column. And now for line 56, we have another for loop with an inner for loop with a nested if statement with another nested if statement with 3 nested if statements. So what this section of the code does is that it picks a figure to activate, and we find the length of our newly made index, which we made in the previous for loop. Then we check if the value is empty or not. If it's not empty, we extract the x and y value of that index, and then we use that to extract the corresponding bounding box value in our bounding cell matrix we made previously. And then using that value, we temporarily store it in a value named g. Then we check if that value is also blank, since there are values in the bounding cell matrix that are empty. And if the value isn't empty, we then check if it's less than 400 or greater than 150 in terms of the scale used for images in MATLAB. This is to ensure that things outside our region of interest, or things that are unreasonably outside a certain area which we want, don't get marked as tumors. Now we use the rectangle function given the position that we have in our bounding box matrix. We make a rectangle around the tumor that we've isolated. And then this loop will repeat for each figure, which has its own corresponding image. And that would result in each image having its own figure with its own set of isolated tumors. And that's our code.